Welcome to my channel. Good day. I hope you are doing well and have a great day. Today we will explore Amazon EKS Auto Mode, a powerful tool to simplify the Kubernetes management and automate the infrastructure. Let's dive in and see how it can transform your Kubernetes experience. Amazon EKS Auto Mode is a new capability that streamlines Kubernetes cluster management. It automates the provisioning of infrastructure, the section of a compute instance, dynamic scaling, and optimize for cost. It reduces the need for specialized knowledge in managing the production grade Kubernetes cluster. What does Amazon EKS Auto Mode? EKS Auto Mode provides an automated management of a compute, storage, and networking management for Kubernetes cluster. It automatically deploys the essential control inside the AWS managed environment. It launches and manages the EC2 instances and scaling and optimize the data plane as the application requirement changes. EKS Auto Mode, in nutshell, I will call it as an automated scaling, automated provide updates, and we can call it as an automated scaling, automated availability, automated upgrade. So EKS Auto Mode is provides you the automated scaling of your application based on the demand and ensure that you have the right amount of resources up at all times. And automated availability, auto mode ensures the availability of your application by automatically managing the scaling the availability of your Kubernetes workload. And auto upgrade, auto mode provides you an auto upgrade, make it easy to keep your cluster up to date with the latest Kubernetes release. So this overall makes our work in ease to manage the EKS. So the key feature of the EKS Auto Mode, as I covered, it can provide automatically the provision the servers of which can provision the EC2 resources, instances, and EBS volumes, and dynamically scale, adjust the resources if the real time based on application demands, and cost optimization, continuously optimize your compute resources to reduce the cost, and security is in first priority and make sure your OSs are patched and securely updated automatically, and simplified management and reduce the operations overhead by adhering to AWS best practices. So here before the auto mode, what is the architecture? So the architecture here is like earlier we were having the control plane. The only control plane will be managed by AWS, and this rest of this portion will be managed by us, like this Amazon CSA driver, Carpenter, EKS pod, CNI, load balance, and the core DNS, and especially the EC2 instance. This is the has to be managed by our side. And after the auto mode, now the Amazon will be managed the entire portion of this managed control plane, managed capabilities, and EC2 instance on their end. So let me dive in further how it is done. So this is a shared responsibility model with EKS previously. So Amazon normally manages the global infrastructure, foundation service, and the cluster control plane. In the cluster control plane, we have the API server and the HCD database. So the user capabilities are mainly the cluster capabilities, cluster EC2 instances type. So mainly like on the cluster capabilities, the compute auto scaling, pod network policies, elastic load balancing, and storage drivers. And for the cluster EC2, mainly the lifecycle, operating system, patching, monitoring, and health and repair. So this will be our head, like from the user end, we have to manage this all, and also we have to ensure the application availability, security, and monitoring. So when we coming to the shared responsibility in the auto mode, so be with the auto mode, the 90% of our work, the 90% of the work is means I will say 80% is completely eradicated. So AWS will manage the all the workload on the backend, like the global foundations, global infrastructure, foundation service, EKS cluster control plane, cluster capabilities, and cluster EC2 instances, which means they take care of the compute auto scaling, network pod network policies, pod networking and network policies, elastic load balancing, storage drivers, and the EC2 management, the lifecycle, operating system, patching, monitoring, and health and repair. So our part, only the application team's responsibility is to take care of the application of the containers, their availability, security, and monitoring. So this is the architecture of the EKS control plane. So EKS auto mode, I will call it. In the EKS auto mode, we have the control plane where the API server and HCD database reside, and which manages the handle the Kubernetes operations like scheduling and health monitoring and the lifecycle management. The data plane, we have the Carpenter. Carpenter is a key component for EKS auto mode. So In the carpenter will normally what does is that is dynamic node provisioning, on demand node creation. It automatically provision the EC2 instances when the new pods are scheduled. Select the instance type and the size based on the resource request and the right size nodes basically. So well, whenever we have the we want to optimize a type of number of nodes based on the workload requirements, example CPU and memory or GPU, and at the same time the cost optimization. So using a easy to spot instance and on demand instance to minimize the cost while maintaining the application performance, and packs the workload efficiently to reduce the number of utilized nodes. And auto scaling, even Carpenter has the facility of auto scaling. Scale the cluster horizontally by adding or removing the nodes based on the workload demand. And response to change the faster traditional autoscaler like Kubernetes autoscaler. Self-healing. So when coming to self-healing, monitoring the node health and automatically replace the failing or underperforming nodes. Lastly, the multi-availability support that distributes the workload across the multi-availability zone to enhance and reliability and resiliency. The next slide, we will be talking about how the EKS auto mode work with Carpenter. So when a user tries to deploy a pod or a deployment to the auto mode cluster, there is a resource monitor, mainly a Kubernetes scheduler, determines in the pod placed on available resources. If the resource is insufficient, a Carpenter trigger the scaling action. The scaling action is basically the Carpenter interact with Kubernetes API to access the cluster needs. It provision the EC2 instances to the best fit for the resource requirements. Example, a GPU for ML workloads and high memory for databases. Node management. Nodes are automatically labeled and tagged to match the workloads, and unused nodes are gracefully terminated to reduce the cost. And application execution. Finally, the pods are placed on the new worker nodes and they ensure that they are available and start the process on the workloads. So coming to the main advantage of the Carpenter, faster scaling, intelligent instance selection, integrate with AWS services, and the workload awareness. So key functions of the EKS auto mode. As I stated, since they are using at the backend the Carpenter, it takes care of the node lifecycle management, system process, and automatic updates. The advantages of using the use cases and the configuration, high availability, custom compute selection, and application best practices. High availability, configure a pod topology, spread constraints for high availability across the nodes and the zones. And custom compute section, use your Kubernetes label to specific compute requirements for your workloads. And application best practice, implement the pod distribution budgets and resource requests and limits and gracefully shut down them. So what I've done is that is this is about in this slide what I'm going to talk about is how are we going to provision the EKS auto mode. There is various way to do. So there is three options which can be taken up. So we're either using to console or AWS CLI and Terraform. For our demo purpose, I can show you this two portion, but I've already done the Terraform portion. I can share that to you. Yep. So I've done the Terraform part. So before going to the Terraform part, I can also share you the EKS CTL command as well. So these are the commands that we can use for the Terraform for using EKS CTL. You can also run this command in your CLI or in your shell to ensure that you have this package get installed, and you can try to run the auto mode cluster setup build using EKCTL. So first we have to build the EKS auto mode cluster, and then we can provision with the respective VPC siders and the zone. And this one I've taken to the Terraform part. So here's my Terraform code. So what we have done is that is we have taken the VPC provisioning. We are provisioning the VPC in the three availability zones in US East 1 and East B and C. And in this case, like we have the respective NAT gateways are enabled, and what we are doing, a next step is that is like we have the locals.tf file where we specify the name of the cluster. The name of the cluster is EKS auto mode, and in the EKS cluster, we this is the Terraform main code where we call the module with Terraform AWS modules with the version number 20.31. I've specifically mentioned the version number as 1.30. The reason is that is I want to make an upgrade plan either via console or using the Terraform. So you can change the version because the reason is that is auto mode can take care of your cluster upgrade on the fly, and earlier days it is very tedious. You have to go update manually, or you have to upgrade it. It takes huge amount of time, but having enabling auto mode, the process it gets streamlined. It's quite faster, and the cluster version is 1.3.0, and the major key portion of enabling the auto mode, this is the parameter, the cluster compute config enabled equal to true. This value will trigger the auto mode function in the EKS, and we are specifying the node pools. Mainly the node pools are general purpose and the system. For the general purpose systems, we are only restricting only T3 and T3 small and T3 medium, just for the demo purpose and costing wise. Explicitly, we're not going to use M5 large and M5 n large. So, and the backend is Amazon Linux. It also supports the Bottle Rocket OS as well. Yeah. So, and the other part is that is the node pool. This is the node pool that we are planning to use. So the node pool will create the functionality of spreading the topology, which instance to be used, which instance not to be used, and we can call the spread of the zones, availability zones. I currently choose two zones. If you want, I can have three zones as well, and the type of architectures that you want to bring up on the server, and also limiting the size to 4 CPU and 16 GB RAM. So I've already ran the Terraform commands just for your reference. I'm running this up. So just I initialize it, plan it, and apply it. The code is already available in the GitHub. I will put it in the description channel. You can just clone it and run the Terraform portion. It will be much quicker and faster for you. Now let's run the export command and connect to the cluster. Yes, we're connected to the cluster. Now we're going to apply the node pool. Yeah, so let's check the node pools. How many node pools? We normally will have two node pools at the moment, and you can see there is zero nodes available here. So there is zero nodes available now. For the demo purpose, I have taken the applications, mainly the first application is to deploy a sample inflate workload to Amazon EKS Automode cluster. What we are going to do in this is just we're going to deploy a pod. What will happen in that case, when you deploy the pod, automatically the pod is scheduled. The scheduler will see whether the resources are there. It will trigger the, if resources are not there, it will trigger the carpenter to create an instance and schedule the pod there. And next demo is that is we can deploy a sample load balancer workload to the EKS auto mode that will take care of your provisioning the same model, like see the where to check the scheduler, and scheduler see whether the resources are available. If it is available, it will use the existing, or it will use a carpenter to trigger. In this case, it will also trigger the network load balancer setting. We are going to use application load balancer and map the application load balancer for us. And last one, it's also take care of the stateful workload, which is basically it can provision your EBS volume. The good functionality of the EKS auto mode is that is even the storage is also automated. By default, all the storage classes like the EBS volume and EFS volumes are attached. You can just try to run the deployment only. So it will be taken care by the EKS auto mode. So let's go to the demo part. So this is the demo for 0.1. Let's get in there. So let's first check the node pools, the nodes on the server. So we don't have any nodes, no resources found. Let's deploy the application. So what is there in this? You can just see a sample application. So we are trying to deploy a normal deployment with one replica. That's it. So let's deploy this now. Yep. So now let's see what's happening at the background. So you can see the pod has get been initiated. It go to the scheduler, and currently the scheduler sees there's no nodes are available. Warning failed to schedule, so no nodes are available to schedule the pod, and the carpenter will be triggered to create the instance. Meanwhile, let me open the console. Yeah, you can see there is no node, so immediately carpenter has triggered and created a workload for us. Here is our brand new, and you can see the pod already get provisioned. I think pod get scheduled right now. So let's check the kubectl get nodes. Yep. So kubectl get pods. Yep. So you can see the pod is running now. So let's go to the cluster on the console. So this is the after provisioning, we can see this EKS auto mode as this is the cluster name. So when you can also migrate your existing cluster, production clusters or the development clusters, you can to switch to the auto mode by just clicking this manage the auto mode and click enable. So there's only a prerequirement. The prerequisite for that is you need to have the cluster roles for that. One for the auto mode cluster and the node management role. So mainly we need to have the this particular IAM roles that needed for that. You need to map it, and once that is available, you can ensure that you can able to enable the auto mode. So these are the policies that need to be attached for on the control plane for mainly for the EKS auto mode cluster. And the node, there is a node management that two policies IAM policies attached. You can map it on and then enable the EKS auto mode. So coming back to the compute part, so we have the currently earlier where we don't have any compute instances. Now only we have T3 medium instances. So let me go to the next demo. The next demo is similarly as I discussed, like we will be deploying an sample application within the namespace called game 208, game-2048, and we try to deploy the two replica of this application and then expose that service, and we expose the service at the backend on port 80, and the ingress is basically to spin up an application load balancer for us, and then we configure the in first we configure the ingress to expose from the application load balancer to the context path slash to the backend port 80. So let's get that deployed. So I'm just going to deploy it, and we'll see what is happening. Currently we have one node. I think I'm going to terminate this pod. The reason is that is we want to see how carpenter going to really behave at the back end. So once I delete it, the normally the node will be available, but when we go for the when we check for the instance level, now we can see normally carpenter keep watching it and see if the instance is idle, it will terminate the instance and remove out of it so that it saves the cost for us. But however, for the demo purpose, I don't want to waste the time here. Let's dive into the next demo with the interest of time. So I'm going to provision this controller ingress application, and later we will scale it. Let's go and deploy this part. Let's check on the events. I think one node is really sufficient for us at the moment. Yeah. So I think the instance is terminated and is trying to claim for the node. I think I've deleted the inflated pod, so the node was terminated. Now we can wait and watch whether we are getting any new node or not. So that is the advantage of the Carpenter, the EKS auto mode that manage the underlying infrastructure. So let's wait for it. And meanwhile, let's see. See now the node has got provision. Node is not ready right now. By the time I think it should be ready now. Let's check on the console. Let's refresh it. Yes. So it is going to. I think it's going to provision. Still showing us unknown. Yep, you can see the new instances created just few seconds ago. The previous instances that we were deploy the deflate one that has gone and we got the instances. Now let's check the EK load balancer part whether it is getting provision or not. Maybe it takes some amount of time in my opinion. So the load balancer is an application load balancer. So let's check the load balancer. Yeah, it is still provisioning. I just pause the video for a while. Once the load balancer is available, we'll resume the video. Thanks for your time to join back. So what we have done at the moment is that is like we have provisioned, just to recap on it, we just provisioned an application load balancer, which is on the three availability zone, as I discussed. So what we have done is that is we are deploying an application gaming application, and we are trying to go with the two deployment. Initially, we see that node was not available, and it's provisioned a new node for us, and then put it to the load balancer, and we are trying to expose this application on port 80. Now let's access this application so we can see whether how the application behaves. This is the DNS name. Let's capture it. Continue to the site. Yeah. So the application is available and ready to access. So now in this case, in the control plane or in the console, right now we have only one node. So let's scale this application and see how dynamically it can auto mode can trigger the instance provisioning. Now let's check the events at the backend. So we can see there is only we have only one node. So Carpenter will scale this instance and provision the deployment of the pod. Yep. So you can see automatically the node get provision, and let's see this application is deployed. Yeah. So the containers are get created, and we can still access this application at the backend. So this is the one cool feature I can say with the Carpenter with the EKS auto mode. We can still access the resources, and AWS at the backend automates all the workload at the backend for the users, end users. The last one is the storage part. So let's go with the storage as well. So this one, in this case, in this demo, it is also a similar option. Like what we are going to do is we are going to deploy a stateful application. So we are going to deploy a stateful application, And before that, what we're going to do is that is we are creating a storage class to get mounted, which is basically a GP3 storage. Uh, and at the same time, like we will be deploy a PVC. So let's do that now and see how it behaves with Carpenter with EKS auto mode. So now let's check the it's done. So this is also automated at the backend. So we didn't install any CSI drivers. So let's see whether the storage class has come up. So let's check the PVC. Yes, the pounder. Let's check the pod now. So now we can get the PV details on by describing the EC2 instance. But for our case, like let's log in and see whether we can able to write inside the pod. Yeah. So we can able to see the underlying persistent storage is also created dynamically and assigned to the cluster. Yep. So wait for a second. Yeah, so you can see this is a persistent stateful set application. This is a stateful set workload, and we can see the AWS EKS auto mode could able to provision the EBS and the storage automatically. So coming back to the slides, in next slide we will just compare the feature comparison, the main feature comparison between the EKS auto mode and EKS standard mode. On the EKS auto mode is the node management scaling. First, the node management is fully managed, whereas this is user managed. And scaling, it's automatic and optimized. It is customizable. Target audience, beginners, and the team want simplicity. This is for the advanced Kubernetes users. And the use cases like quick setup and auto scaling, fine tune and custom setup for the EKS standard mode, and operational complexity it's completely reduced, whereas in EK standard mode still higher at the moment. Cost efficiency it's completely optimized, focus for cost. So if I can terminate automatically, all the nodes are being removed out from the cluster. And this is a manual operations at the moment, still we have to do this. And we are worried like when we remove from the node groups whether we'll have problem or not, we normally worry about it. And security and the compliance, so much improved. They do have the managed updates and patching integrated with AWS, and security surveillance are enhanced with cluster security. This is managed by completely by the user. I can call this really good feature. And flexibility limited, but anyway, so with this less flexibility, we can I think we have the leverage to use so many features. But when it comes to our standard modes, yes, we have full control of the cluster configuration, networking, and the compute section. So scaling beyond the default limits. So you know the Amazon EKS auto mode as an HPA automatically scales the number of pods based on the CPU usage and other metrics. And the metric servers are normally collect the resource usage and data for HPA to make the scaling down. And the dynamic node scaling, EKS auto mode scales the EC2 instances based on the workload demands. So the benefits of the Kubernetes auto mode, I will say like it's mainly for benefit for the Kubernetes users who have less knowledge on management of the EKS cluster or the Kubernetes. They can just spin it up, and that case they can reduce the operation overhead, improve the performance, saves cost, and maintain the security and compliance. So in conclusion, the EKS auto mode simplifies the Kubernetes cluster management by automating the infrastructure provisioning, scaling, and optimization. It completes with existing EKS offering and provide flexibility for both simple and complex workloads. Users can still use traditional EKS for options for custom configuration, offering wide range of use cases. However, you can refer the EKS documentation. Thanks for watching my video. Have a nice day.